Welcome back, AP Stat. This is an additional section talking about chi-square test statistics and how they relate to p-values for chi-square tests. All right, we're going to specifically talk about computing a p-value given a chi-square test statistic. Recall that the p-value is the probability of finding data like ours given the null hypothesis is true. So assuming the null hypothesis is true, what is the probability of finding data as extreme or more extreme than ours? Okay. As with other test statistics, given the value of a chi-square test statistic, we can compute the p-value, all right? So there is a direct relationship between the test statistic and the p-value. So for a chi-square test specifically, the p-value is the area under the curve to the right of the test statistic, and that will influence our computation, okay? So we remember that the chi-square model is a right skew model, and we care about the right tail when we are computing p-values using a test statistic. So let's look at problem number 1 here. Given a chi-square test with 10 degrees of freedom, find the p-value for a chi-square test statistic of 14.5. And we are going to use chi-square CDF that you will find in your calculator. Let's get to it. So here we are at the calculator. We're going to go to second distribution, and way down near the bottom, maybe not that far, is chi-square CDF. We're going to hit enter, and we are going to type in 14.5 for our lower, and our upper is going to be an arbitrarily high number. This will help us find the area under the chi-square model with a specific number of degrees of freedom to the right of a test statistic of 14.5. Now, the degrees of freedom is 10, all right? We'll just put that in, and we will hit paste. And then we'll hit enter one more time, and that will give us our p-value, all right? So that is a pretty high p-value. We would probably not reject the null hypothesis here. Now let's look at our second question. For the two-way table below, a test for homogeneity gives a statistic of chi-square equals 4.14. Find the p-value. So first we need to find the degrees of freedom for a test for homogeneity, and then we're going to use chi-square CDF. For the degrees of freedom, we would look at the cells, all right? Ignoring the margins, let's just look at the cells in the gray right here. The test for homogeneity features degrees of freedom of this kind. Number of rows minus 1 times number of columns minus 1. Now see, I have 2 rows. 2 minus 1 is 1. I have 3 columns. 3 minus 1 is 2. 1 times 2 is 2. That means I have 2 degrees of freedom. The rest we will handle in the calculator. So here we are again. Let's go to second distribution, chi-square CDF, and we will say 4.14. That's going to be our lower. Our upper is 10 to the 99. Degrees of freedom we would say is 2. We hit paste, and bada bing, bada boom. Another pretty high p-value probably would not reject the null hypothesis in this case either. One last thing, just want to talk about what computer output might look like for a chi-square test. This is a screenshot from your textbook, okay? So this is on a study about police car searches, and how that variable is related to the variable of the race of the person driving the car. You can see this study in chapter 25 in your textbook. Okay, so we have the variables. We have the variable of a search, whether yes or no, and the race of the individual, black, white, or other. Okay, and you can see that in the table down here. So the degrees of freedom would be 2, which makes sense. I'll let you think about why that's true. We see our chi-square test statistic, which we've been talking about a lot over the past few minutes, and the p-value being very small. All right. Um, then we can look at the observed counts up top, which are the whole numbers, and the expected counts, which we expect, to be not whole numbers. We expect them to be decimals, right? So that is how you would interpret computer output for a chi-square test.